Hi, this is Jeff from the Ozark Mountains. That's in Missouri, in the USA. Well, today here, sitting on the desk, we've got some stuff I recently got in from Japan. And what I was really interested in this lot of stuff was the Sharp CE162 parallel and cassette interface for the PC1500. It came with a PC1501. This is the Japanese version of the what was called the 1500A in the rest of the world. And it had this interesting Sharp CE515P printer, which is kind of a larger version of the Alps mechanism that you've seen me work on several times before. But it's not just larger, it is a different mechanism altogether. So today we're going to concentrate on this printer. I tried to look on YouTube for something about it, but nothing. Fortunately, it did come with a user's manual, but it was all in Japanese. So I scanned that and used the Google image translator and got an okay English version of the manual, at least enough to learn how the thing should work. And we're going to have to take it apart to see if it looks like it will work. Some other things before we plug it in, but then we'll see what it does. So let's get started. Thanks to PCBWay for sponsoring this video. They do circuit boards of all sizes, small circuit boards, medium circuit boards. They can even assemble them for you. They also offer a wide range of services that allow you to go from idea to a finished product, including CNC machining, 3D printing, injection molding, PCB assembly. Go on over to PCBWay.com/OEM to find out more. So here we have kind of the family tree of these Alps printer plotter mechanisms. Here is the baby of the group. These were the first ones that were out. These came out on the pocket computers. This is, I don't know, about 60 millimeter wide paper, I think 58 to be exact. 4 color pins. Very clever mechanism. So these were used in everything from pocket computers back in the day to medical chart recorders, just everything. Then we have this larger kind of 40 column printer plotter, which is more like, I don't know, 115 millimeter wide paper. And I've got this one apart because I have been tinkering with it. And you can see, maybe if I get this a little closer, that these are the same mechanism. This one's just wider. That's the only difference mechanically. Otherwise, other than the width, they are the same. You might notice this bright white set of gears right here. I've actually 3D printed these and I've been trying it on this printer. So far they're working pretty good. The way Alps designated this is the x-axis was the carriage feed. The y-axis was the paper, and the z is the pin, and the entire z mechanism is this flipping forward, which bumps the pin up against the paper, and then the z-axis can also rotate to rotate the pin around. It does that by banging it into this side like this. You can just see that rotating around. Maybe I can show you better on here. So it comes over to this side and hits it 3 times to rotate it around, like that. And then we've got this big boy right here, which can go up to A4 wide paper that does have a flap here to take the same width of paper as this guy, but obviously this roll won't fit in here. This is the roll from this sort of thing. So we'll take this one apart now and see how it compares mechanism wide to these two guys. Okay, I am trying out a new overhead camera mount. This is kind of like version 3. This one brings the camera out more this way, so when I reverse the shot so it looks better for the video, it looks like you're looking this way, not this way, without as much distortion. Anyhow, we've got the unit here. Picking this up, it's much heavier on this end, and it's quite a heavy unit overall, so I'm guessing there's a power transformer in this side, and I am hoping that it will work on 120 volts. It has a US compatible plug on it. While Japan is 100 volts across the whole island, it is split down the middle, or relatively down the middle. Half the island is 60 hertz and half the island is 50 hertz, which I find rather interesting. I forgot to press record when going over the operator control panel and the connectors on the printer, so we will use the user's manual, which was automatically translated from Japanese to English. So you can see on the control panel we have a single power LED, a paper feed forward, and a paper feed backwards key, as well as a key to rotate the pin carriage around to change colors, load pins, that type of thing. On the back of the printer we have the power connector, the power cord entry, a ground terminal to ground the printer to an earth ground, a standard Centronics parallel port connector, an RS-232 connector, which with the dip switch settings there to the right, you can set to also accept TTL levels, the dip switches, and a reset button. And speaking of the dip switches, here they are. Switch 1 is the word length 7-bit or 8-bit. Switch 2 is the interface type parallel or serial. Switch 3 switches between two variations of the Japanese character set. I don't fully understand what that entails. Switch 4 is the line ending, whether it's carriage return line feed or just carriage return. And switch 5 sets the RS-232 level. L1 position is the normal RS-232 levels, and L2 is TTL compatible. I'm missing a couple rubber feet here. These seem to be smaller diameter ones than I have on hand. I have to try to find some of those. Luckily, it looks like our screws are not under the feet. I could not find a service manual in any language, so we're going to kind of wing it. Okay, I'm going to set the screw out in front of the hole to ensure that all the screws are the same size. This silver paint on the plastic tends to throw off the auto exposure, so bear with me. It's also worth noting that you need to be careful in trying to clean the silver paint. Alcohol will tend to dissolve it. It's good to be mild. Just use some mild soap and water, Formula 409, something like that. Okay, all the screws are the same. That always makes things nicer. It's a sign of attention to detail when things are designed, I think. Because that makes production easier, it makes repair easier. Now this chip says CE515M. Copyright 1984, and if I understand, that is the character ROM, and this 515M is the JIS, the Japanese character set ROM. And evidently there is a rest of the world ROM as well, and some people have that, but I have yet to find a ROM dump of it, or an English language manual. Okay, so now the bottom's definitely the heavy part. So yeah, okay. There's a plate here that the cover is catching on. We'll try to get those screws out of there. I bet these both match. Sucker's just a little difficult to get out of there. And got flaps flapping all over the place here. Wow, that's an interesting transformer, isn't it? It's kind of squat. Big old star ground here. Ginormous power supply board. So we've got our diodes standing up right here. It's going to be hard for you to see from that angle, but they're up off the board, so they'll cool down. A big smoothing cap, couple fuses, perhaps input and output of the transformer, couple transistors, some more capacitors over here. Frame grounds going off to things. And this is our control wires going to the buttons. It looks like this gear set is the Y-axis drive, the paper feed, and that looks just like the other printers. Same gear. Yeah, and it's driving a rubber roller with teeth in it like the other printers, and this one slides when you adjust the paper width. That was clever. So, yeah, it looks like it's a little bigger stepper motor though, but the same pinion gear. Doesn't feel like this one's cracked, but we'll have to get a closer look at it. If I can put some pressure on it. Yeah, okay. That's good. X-axis. Stepper motor's mounted over here. I'll get you a better look at everything from the front view here. Same pinion gear. Simplified setup because the motor is vertical like this. And yeah. Same sort of anti-backlash gear set here on the spool. And what drives our Z? There is a gear around the pins right here that rotates them. The best technical explanation I've seen of this was in the Sharp 1600P manual. Oh, here we go. There is a bar back here. Oh, so it rotates one direction, and that rotates the pin. And the other direction pushes the pin down. Oh, that's clever. So they're getting two axes of motion out of the same motor. Yeah, you got to get it in just the right position for that rotation to work. Okay. I'll get you a closer look over here. And I'll get an idea how this works. So far mechanically, it's looking pretty good to me. Here is a close-up of the X-axis drive. You can see the stepper motor just down here. And actually it is the same as this small carriage. And the rest of the gear set looks just about the same too. This has a top hat on it, whereas this one doesn't, but otherwise they are pretty identical. This is the Y-axis drive, so you can see the shaft from the stepper motor here. Intermediate gear, the anti-backlash gear set, and this is exactly the same as on the small mechanism too. And luckily this one is not, oh, I take that back. Yep, that is a crack right there. So hopefully this will hold on long enough for testing, but usually what happens is these pinion gears break and the hub from this anti-backlash set breaks. So these I've had brass replacements made for the pinions, and these I'm experimenting with 3D printing some replacements. Okay, I've got things tilted up here to show you the Z-axis drive. So that is the stepper motor pinion, which is a little different from the other two. This is the gear set. It has some cams on it, and it drives this bar. If I rotate the gear, it's driving that bar, and that is what rotates and pushes the pins up and down. So if I can get you on the pin set, I can raise the pin, rotate it one direction until you get that kind of that click like that. Then you can lower the pin, rotate it the other direction again, and it'll go back around. That's pretty slick. So 2 axes of freedom with 1 motor. Again, now with a nice simple mechanism. And here is that movable feed roller for the paper feed. Right here, it's a rubber roller with a little spiky thing in between. Since it's running the paper in and out like this, for the plotting action, it needs to keep a firm grip on it. Just friction feed wouldn't do, so it actually pokes tiny holes on the edge of the paper. Okay, so mechanically we know we have a broken hub on the Y-axis paper feed gear. It seems to be doing okay for now. So it might let us get through some basic testing. So here is our power supply board. I've disconnected the AC input from the transformer, and I've disconnected the DC output to the control board. I suspect it's a 5-volt output, so we will measure the AC input and see how much higher it is than the DC output. Generally, you want, with these type of linear regulators, let's say 4 volts or so of greater input voltage than the output voltage that you want. So it would be typical to see 9 to 12 volts input for a 5-volt output. So we'll see what we've got here. I've got my bench meter set to AC volts, and power switch is off. Plug the leads in like so. Reach back here and turn the power switch on. And I have about 12.25 volts AC. That's a little on the high side from what I would want, but I think it will probably work okay. Okay, now we'll measure, still got the DC output disconnected. We'll measure the AC input since it has a slight bit of load on it now. That's still about the same. Okay. And I'm going to switch my meter to DC. it on and then carefully we have, I've got the meter leads backwards, but we have 5.1 volts, almost 5.2 volts DC. So I think we'll be okay. This will run a little hotter, but it's got a decent heat sink under here. And the whole thing isn't going to draw that much power, so I think we'll be fine. Okay, I've got everything plugged back in, ready to power it up. I'll move the carriage part of the way down here. So my guess is if it's like the other mechanisms, it'll move the carriage that way to home it. Not sure how it knows it's home. And it might rotate the pins around. That's what the other one does to put black out. Yeah, but we'll see. Turn the power on. Okay. Just seems to be deadheading into that wall. So there's probably no sensor. It's just driving long enough to go from this end to this end, timing out, and then rotating the pin carriage. So let's turn it off. Slide it all the way down to the other end carefully. Okay, turn it back on. I'm not sure about the pin rotation. It seems to be kind of lumpy. But I'll get some Q-tips and wipe down these rails that the things slide across. Put the thinnest coat of some lithium grease on there. Not enough so that you can see it, but just enough so it's nice and slippery. And put some fresh pins in, and we'll see if we can get this thing to print. Some handheld shaky cam here. My curiosity got the better of me, and I took the printer mechanism loose to get a look at the main board. And you notice there's not much on here. We've got our dip switches, a little DC to DC converter here for the RS-232 port. We can see the footprints from the ROM. Some buffers, electrical connectors, parallel interface, and we notice the board says ALPS 64N0101-04 ALPS, made in Japan. So that makes me suspect that this is not just an EEPROM, that is actually a microcontroller. And I think on the other ALPS board from the other wide carriage, those were a 6300 microcontroller, which is a 6800 based microcontroller. So I'll pop it up here on the screen after I research that again. I'll have to look at one of my old videos to be sure. The bottom of the printer mechanism, you can rotate that around carefully. It's pretty simple. The motors, all three of them are the same. The Z drive here does have a different pinion gear. Otherwise, they are the same as the smaller mechanisms. Okay, I installed some working ink pens, and the way you do that is you pull this lever towards you and rotate it up. That releases the pin, and if you just push down and release it up, it's got a little spring in there that'll pop it right out to you. This is the good pin, so I'll leave it in there. Rotate that forward and then push it back. Okay, using some of that roll paper now. The roll I have is too large, so I just cut some off, fed it through there using the paper feed key. Now, according to the manual, which was in Japanese, if I hold down color change and press paper feed, it should do a test print. Okay, well that ran through the motions, but it didn't print anything. Let's try it again. Yeah, going through the motions, but nothing's coming out on the page. Huh. Yeah, I'm sure these pins are good. Okay, maybe there's something in the bottom of the pin holder that's not letting it poke through. It seems to get pushed all the way down. The top edge of the pin lines up with the top of the thing there. Huh. Okay, so it's making the motions but not making the marks. So I'll have to look into that some more, and then I'll have to figure out how to program this thing to actually print something useful. Okay, after some fiddling, I finally did get this to print really nicely. I want to show you the test setup here. I have a TRS-80 Model 100 that I have a program on, which was modified from the MCP40 manual. The syntax on this printer is a little different, so I had to modify it some. I was having problems with the test squares that it prints out. And yeah, it just wasn't really consistent how it was printing, and I tried different sets of pins which seemed to be okay. And then I finally thought, well, maybe it's the paper, and I tried just a scrap of printer paper, you know, like for an inkjet or laser printer, and that worked fine. So, and so this paper has a slicker finish. It's slightly thinner, but even if I tried doubling this up, it didn't print really well. This stuff prints good though. And I noticed that I had set a print width here. It just got close to the edge and then automatically wrapped around. And that didn't really dawn on me at first that that was different. And when it got to the bottom of the page, it would stop here, and there's supposed to be several different line types shown here. But after it fed the paper that far, the carriage would just go back and forth and it wouldn't try to print. And I thought there was a problem in my program, and I tried a full sheet of paper, and then it worked fine. And it occurred to me there has to be a sensor in here that when you set this right-hand guide, the printer knows how far over it can go. And it also must see when the paper's out. So, I didn't notice that at first when I took it apart. I reviewed the footage, and I see some wires heading up into this area, so we'll take it back apart when we're done with this test and see how that works. And let me go ahead and run this paper out here. And we can see that with the same program, it took up more of the available page to print this continuous line, and the printing looks really good. So I will feed this back through on the back side like this. And it says in the manual it needs to go through about that far, and I've kept the clear cover off here so we can see it printing. And I'll get you pointed down a little more toward the carriage so you can get a better view of that. Okay, I haven't run this for more than a day now, but the pin should still be okay, I think. I'm going to run the test program. You see, it doesn't need to go all the way back to the left to rotate the pin like the smaller mechanisms do. These dashed lines have an interesting tone to them. There we go. And that last color change was at the end of the program. So nothing fancy, but it's a nice little program to show that everything works fine. So I'm very happy with that. And as you can see, even on this 8.5 by 11 paper, it centered the text really nicely all by itself. It's doing a good job even with some original 40-year-old pins. Okay, I did not put all the screws back in this guy, so I'll get the camera back overhead and we'll take a look inside at what is allowing this thing to sense the paper size and the paper out. Okay, a little handheld shaky cam here. So I've got it apart with the printer carriage flipped upside down. And there's these extra 5 wires here that goes to the circuit board. And you can see the bottom one is a common, and this top one is divided into segments with separate leads off of each one. So these contacts are contacting different areas along here. So it knows what width the paper is, and it must guess at the length the paper should be based on that width. So if it senses it is the width of the roll, it's going to assume it is continuous, and if it's a different size, it's going to say, oh, that's A4, so it should be about this long, etc. So that's kind of interesting. I didn't notice that before when I had the carriage out. So just a very simple contact strip. So kind of like the rest of the carriage, Alps did a lot with just a little bit of mechanics. Very nice device. Well, we got our little Sharp CE515P cleaned, lubricated, and tested. It's a nifty little printer plotter. It's amazing that Alps started out with this little mechanism here, made an even bigger one, and then modified just a little bit to make this full sheet sized printer. It's really impressive what they managed to accomplish with a small amount of mechanics. It's actually much simpler than, you know, a dot matrix printer back in the day, and much more versatile, but a bit slower. I did take the pins out. Always store the pins in the tube with the caps on them. You know, these have been stored that way and they've lasted 40 years. I've got a few sets, so I think I'm in good place. I'm really happy with the print quality on this. Found out that the right paper is important. I was also curious after running it when we took it back apart to check that paper width sensor, how warm the power supply section was. It wasn't. I looked up the two, they're marked as transistors on the board. I looked up what those were. There's an LA5005, which is a low dropout 5-volt regulator, but it only has a 60 milliamp output. The other part is a 2SB983 transistor, which has a 7 amp output. So they're using that transistor as like a current bypass, or they're using the regulator to drive the transistor in some manner. So they're getting the regulation plus the increased current. Since the transistor is mounted to a nice heat sink and it's able to handle the current, I'm not worried about running this 100 volt Japanese unit off 120 volts. It'll be just fine. We talked about what I thought was a ROM chip originally. It turned out to be the microcontroller. That in the MCP40, which also has the circuit board made by Alps, it is an HD6805 V1P, which is a 6800 derivative in a microcontroller form. I believe that was made by Hitachi or Harris. I don't remember which. I am guessing this is going to be the same thing in this printer because the circuit boards were both made by Alps. So if you have the Japanese version of that ROM and you want to install or ROM, I said it again, and you wanted the US version, it's not a simple matter of programming a new ROM on your EEPROM programmer. It's an actual microcontroller, and if you're able to find a generic unprogrammed one that can be programmed and you can get the code off the old US chip, you might be able to do that. I haven't looked into that to see if it's possible. This prints the normal Latin character set too, so it works for me. If you have any questions or comments, let me know in that comment section down below. I'd love to hear from you. One thing I'm thinking of now, just off the top of my head, is maybe some sort of program to convert HPGL into the syntax that these little plotters take. It'd be neat. Drawing something of an Inkscape and then printing it out on these. So what do you think about that? Let me know. Thanks to everyone who helped support the Hey Bert channel through Patreon and other means. If you want some more information about that, just look in the description down below for the link. And until next time, bye.